Today's presenting sponsor is Datadog. If your business is being driven by software, you know today's applications are more complex than ever. They're sitting on multiple layers of infrastructure and distributed services, and it can be very complicated to manage. Datadog brings visibility into every part of your infrastructure, as well as APM monitoring for your application's performance. Customizable dashboards, collaboration tools, and alerts let you develop your own workflow for observability and incident response. And Datadog integrates seamlessly with all of your apps and systems, from Amazon Web Services to Kubernetes to MySQL, so you can get visibility in minutes. You want to get started now? Go to datadog.com/cloudcast to get started with Datadog and get a free t-shirt. Datadog is trusted by thousands of enterprises. So if you haven't tried Datadog at your company or on your side project, go to datadog.com/cloudcast to try it out and get a free t-shirt. And now, on with the show.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you live from the massive studios here in Raleigh, North Carolina. You know, there's been this thing that Aaron and I have been kind of discussing and debating for a very long time, kind of since we began the show. And, you know, we were always sort of looking towards the future and trying to figure out where things were going. And we've always had this question of, you know, when the world starts to become completely networked and all the devices around us are networked and all those things, you know, how will we answer the eternal question of, you know, how many IoT engineers will it take to screw in a light bulb? And, you know, it sounds funny, but today we're going to get the answer to that question. So very excited to have with us Thomas Munn from Cree Lighting, great company here based in Raleigh, North Carolina that's been doing just a ton of really good work around green energy and more efficient lighting systems. So Thomas, welcome to the show.
Thank you.
So you have been working in the IoT space for a little while now. Give us a little bit of your background, you know, the type of work you've been doing in the past, and then a little bit of a preview of this exciting IoT project that you've been working on.
Sure. I started out in about 1997. I got a job with Kellogg managing their firewall, which back in that day was a proxy-based firewall. And sort of that was where my security career began. After that, I got into financial services. I did a lot of auditing and, you know, pen testing, a lot of security audits, a lot of, you know, open source. I do a lot of open source security stuff. Okay. So I helped my organizations with IDS, IDP, firewalls, disaster recovery. You know, and I was on the Mercantile Exchange for a while, and that was my first real taste of security. And then that was in Chicago, and then I moved to 9/11 happened, and then that ended all the financial services jobs in Chicago. So then I was in healthcare for a while at St. Vincent Hospital, where I pretty much managed their internet, you know, their firewall and infrastructure. You know, it was a 80 hospital system where pretty much I made sure that they stayed online and that they were secure, and a lot of auditing, a lot of different types of, you know, text processing, that kind of stuff. Finally, my most recent and longest career was with Verizon Enterprise Services, where I pretty much did all the weird stuff. I did like XML devices that were like middleware, translation layers. I did a lot of log analysis and forensics, web application firewalls, F5 load balancer, Blue Coats. I could go on. Yeah. Been doing that for 10 years. So I know infrastructure backwards and forwards, software-defined networking, you know, all that. You know, I grew up in network infrastructure and frankly got bored with it. You know, I'd been doing it for 10 years and it was time for a change. So Cree had a position open, and they were looking for a principal IoT security researcher, of which I am, and it was a nice transition between sort of at Verizon. I left off on the software-defined networking and pretty much, you know, managing things at scale with like Ansible and how do you make an automated security infrastructure, you know, that kind of stuff. Okay. So I did that quite a bit, and then, which was a very nice transition into what I do now, which is pretty much helping to build the security infrastructure and the cloud infrastructure for Cree's IoT initiatives that we're starting to head up now.
Okay.
So that sort of brings you up to where I currently am.
Gotcha. So your background is very fundamentally in security, but just as importantly, a lot of very high profile industries, like you said, healthcare, hospital systems,
and banks,
and banking, financial services. So a lot of systems that people have personal information in there. They're expecting them for literally life-threatening types of things. So let's talk a little bit about we hear all the time about how companies have to become more software aware, more software centric in how they're going to compete in the marketplace. Let's talk a little bit. Cree is a manufacturing company fundamentally. I mean, lots of scientific work that goes on behind the scenes to make the lighting systems. But talk a little bit about kind of culturally, how are they adapting to having to become more software centric as they get into smart devices and things with sensors and things having to communicate over the internet. How's that going, or how does that kind of translate from a culture perspective?
Well, we pretty much have two teams. One team does the more immediate, go-to-market stuff, all of the current things that we're doing, and they're ramping up pretty well. My team is sort of the longer end of the view. We do a lot of the research and sort of take it from the shiny new stuff, reduce the risk, and after we reduce the risk, then we sort of it's ready for production, and then we pretty much roll it out to this other group. At least that's the stated direction.
Yeah.
One of the main reasons that I think that Cree is going into software is that material science and LED technology is now an established field. Mm-hmm. So a lot of the material science is it's become a commodity.
Sure.
So in order to continue to have value in our products, we saw the need to enable smart features and specifically some of the green initiatives, but enabling a lighting system to interact with corporate IT assets to give you a more modern view of what's going on. Everything from your HVAC systems, the intercommunication of all these different systems,
sure,
and to provide a framework that would enable that.
Yeah, so this idea of smart buildings and smart cities and all those types of things. How much of your time do you find? Obviously, you're doing deep research into security and so forth, but you're going to communicate at some point back to a line of business or a product manager. How much of your time do you find you're having to kind of translate between the language that they're used to speaking and all this sort of technical language, software language that you speak on a daily basis?
I'm very fortunate. I mean, at most, probably 15% of my time.
Okay.
Maybe 20 at a high. A lot of times what I do is I do graphics. So we use OmniGraffle, which is a wonderful, wonderful tool, and we'll take the newest, design pattern that we've come up with, and we'll have these lunch and learns where people will come over and we'll introduce them to the concepts, and then we'll, the things that the other group needs, they take, and we sort of enculturating Cree to a modern, rapid deployment, agile style deployment methods, and security as well. Because security is also very new to Cree. Although they've done very good with all their stuff, I'm probably the first person solely devoted to security in the company as far as the IoT initiative goes.
Yeah,
which is pretty cool. I mean, I don't know any company that I've worked for that's ever given me the ability to do that.
Yeah, so you've got sort of a green field within a large brown field environment. That's kind of cool. I think it's interesting and it's smart. Obviously you guys, like you said, you're doing lunch and learns, but the recognition that you're going to take a technical topic or a technical set of jargon and kind of visualize it for people, because people are visual learners, and sometimes that's an easier way to kind of grasp something new.
Well, especially when you're designing security infrastructure. I mean, when we were designing the PKI system, it was so complicated to talk about, but the moment we did a visual picture of it, it was instantly clear. And that's sort of like, when you're talking about these systems where you're going to have a lot of complicated, back-end stuff going on, we constantly use the whiteboard. what I do is once it's all whiteboarded, I transfer that. I love graphics design as a sort of side hobby, so I will translate that into a graphic, which can then be presented to people or used in white papers and things as we go to some of the the trade shows and things like that.
Yeah, very cool. Well, let's talk a little bit about the security aspect of this. There's obviously lots of pieces to it. There's scale, there's security. We'll dig into some of those, but let's talk about kind of fundamentally. I mean, we're talking about lots and lots of little devices that are going to have to figure out how to get secured. You've got to secure the underlying infrastructure for the back end. Like, walk us through some of the key elements that you've had to really dig into that maybe weren't commercially available or you've had to really kind of dig into from an architecture perspective to make this secure and some of your security thinking.
Sure. So, I mean, I have looked at a lot of the existing things out there, such as Thread and there are, Zigbee, Z-Wave, a lot of these, so first thing I'm talking about are the lights, the actual themselves, the endpoints. Mm-hmm. So there's going to be the RF security, how are we going to keep only the lights that we want on our network? How are they going to securely negotiate and communicate amongst themselves, which they don't really do much of, which is one of the reasons we went to cloud. When you go to cloud, the endpoint doesn't have to have any open ports. So that means that the attack surface is pretty much all on the cloud and not on the premises. So that's number one, is that we don't actually have any open ports on the any of the endpoints. There's no open.
So you use some sort of proxy or something in the cloud that emulates those endpoints.
We actually have something called the Cloud Bus Router, which is a central piece of infrastructure equipment, which is basically it's a network overlay.
Okay.
And the endpoints communicate through that to our microservices, which they can have. The second difference is we originally were going to do software as a service, but that was going to be way too expensive from a business perspective.
Okay.
So what we did instead is we're going to the Azure Marketplace. I don't have an exact time, with a Cree appliance that you can download to manage your endpoints.
Okay.
It's fully self-contained, and it can reach out to our larger Cree cloud. Obviously, updates will still be cloud-enabled. So it's sort of a middle ground between software as a service, where we're doing everything, and cloud, where the customer does some of it, and we just give you a nice appliance that, frankly, could even be put in VMware or on-prem as well. That's the other advantage of the model that we've chosen. Okay. So back to the security, though. So the main things that you see in the internet these days is groups use shared keys. In other words, they don't use unique key per device. They don't do both endpoint and software items. So basically, when the endpoints communicate to the central server, the cloud-based router, which is typically going to be in our case, is in Azure in our development employment. It does bilateral TLS 1.2, which means that the server identifies the client and the client identifies the server, which gets rid, and none of the keys are shared. Every single key is unique for every single endpoint. Obviously, CVR keys are unique to a given installation. And more importantly, if you have, like, say, you download for massive studios, and I have my Cree one, your components cannot control my lights, and my components cannot control your lights. So there's that firewall between the two. We call them tenants. So that's the other is a partitioning scheme. The third is a secure-based operating system on which to build the marketplace image. So basically, I was looking for I looked at all the whiz-bang things, Docker and Kubernetes and all these things, but they're right now at a scale that's much larger than we need currently.
Okay.
And more specifically, they're not proven technologies from a security perspective. So I looked for something that was a little more conservative, and there's this thing called OpenSCAP, which is a compliance framework that has 3 or 4. They've got an OpenSCAP for PCI, which is for your if you've got anything doing credit card. It's got one for healthcare, and one for the mil spec. So basically our three major areas that we can go into, specifically healthcare and government, we basically can just give them the operating system, run an OpenSCAP compliance report, send it to them, and we're done. We don't have to worry about being PCI compliant because we're already so much farther above the bar.
Gotcha. So really what you're thinking about in terms of a lot of these different systems, if I'm kind of summarizing this, so everything gets its own unique key, so you don't have people kind of it's not as easy to break into one element of the system. You'd have to
That's correct.
You do that. You make everything unique so that people can't. Now, you couldn't have somebody, for example, break into a building, take a bunch of light bulbs from somebody, and then, or lighting systems, and then install them in their own and sort of take over, because they're not going to work in a different environment. I think. And
yeah, you'd have to reset them. It would be an interesting use case. We're far more worried about a microservice being put in a rogue environment and then controlling the on-prem lights than we are having someone steal the lights and putting them somewhere else, because who cares? I mean, They're in the ceiling. They're not going to, they're kind of hard to remove.
Yeah. Okay.
So the main threat is really a rogue CBR doing bad things to your building.
Okay. Yep.
Which is the primary way why we designed it the way we did.
Right. And obviously, affecting somebody's lighting is one thing, but then when the lighting system gets tied into the HVAC system, I mean, lots of other problems could happen.
Even simpler than that. Well, what happens if they turn out all the lights in a room where there's no windows?
Right. Sure.
I mean so even regardless of whether or not it's lighting is pretty basic and required, especially at night. So it's a very critical system that really needs to be secure.
Yeah, absolutely.
One of the other things we also do is we also are in the process of developing secure firmware that is signed. So we've signed Secure Boot's loader. It's not there yet. We're still developing that. But as we go forward, we're looking at a fully signed software chain of trust. So basically, the bootloader gets signed, the executables actually the important ones get signed, and the updates. Our repositories are all basically they're RPM repos, and they're all signed. So basically, and the signing stuff does not happen on the repo. So if the repo gets compromised, someone can't just put their own software on it and just use the signing key that we've included on the same server.
Gotcha.
So
that's and I think you highlight another kind of a couple of important points is I think people get wrapped up in containers and they say, oh, well, we'll use containers for isolation or something. I mean, you're really kind of coming back to this idea that if your base operating system isn't secure, you don't have a way to manage package management or vulnerability update management. Like the fact that you're using containers becomes sort of irrelevant. The importance of that secure OS is really continues to be a critical thing, especially as you're dealing with large scale.
Yeah, and the second, it's a good segue into, we're looking at a mandatory access control system, which is similar to SE Linux, Tomoyo Linux, which will enable us to basically, we'll be able to use Linux namespaces for every single microservice. So what happens is I instantiate a new, essentially Azure secured Red Hat, which there's a great GitLab thing. We'll have to put that in the notes at the end. And then we are going to institute a namespace for every single user. So like microservice 1 gets user 1, microservice 2 gets user 2. All those users are not allowed to talk to each other. You know what I mean? Just the basic file system. But on top of that, we're going to be layering it with a mandatory access control system so that they're pretty much limited to their own namespaces and to the things that they need to do. Tomoyo Linux is much simpler to do. It does it based on processes. Okay. So I can say process A started by process B, and I want to limit process B to do only these things. And it has much nicer, actually a curses based GUI for doing all it does learning and things like that. And more interestingly is it doesn't require labeling the file system, which on an embedded system, if you've ever used a micro SD on a Raspberry Pi, you know how slow they are. Well, relabeling an entire file system on a light would take hours. So we don't have to relabel the file system since it's all in memory.
Okay.
So that's the other reason why we used it. And it limits everything. So like you can't talk to this socket, you can't go to these files. So and it's very similar to SE Linux. And I've actually seen a lot of bugs in SE Linux these days. There have been a lot of major security vulnerabilities with SE Linux. So I think it's too complicated. And so that's why I sort of migrated to Tomoya Linux. It's old. It's been around since 2008 or 7.
Okay.
And
so trying to follow a lot of the similar principles in terms of security posture, but doing it in a, leveraging technology that's maybe more appropriate for these types of devices or the update frequency and so forth.
Lightweight.
Yeah, it makes sense.
Lightweight.
Sure.
And finally, for our updates, we're largely just using existing technologies. We'll be using RPMs for, the major ones, and then our endpoints are probably going to most likely be OpenWRT based. Mm-hmm. So we'll be using an OPKG. But those will all be signed, whatever package format we use, will all be signed. And that way we don't have to reinvent it because, we're a small company. We don't really have time to have armies of people doing stuff. So.
Right. Well, and that's like you said, it's the power of open source. It's if other people have solved this, there's no point in reinventing that wheel in many cases. So let's talk about the flip side of this, right? Let's talk about scale. Sure. People talk about IoT. We're talking about, at some point, millions, hundreds of millions of devices. Talk about some of the scaling considerations that you guys are going through in terms of, where to run these environments, in terms of the services, or decisions between, do you run these in your own cloud, do you run them in public cloud? Talk about some of those scalability considerations you've got.
Sure. Well, the first scalability consideration is we maintain a constantly open connection so that the lights will be very responsive. Mm-hmm. So the maximum number of units for a single IP address is 65,000. Unless because you 65,000 ports, Now, the interesting thing, though, is we do a layered approach, if you're familiar with SDN, where you basically have a base router. So you have like a root level CBR that goes to another one, that goes to another one. They're like on top of levels of each other. Mm-hmm. So each level is designed to handle about 10,000 endpoints. So we basically load balance the root unit with HA proxy with 2 versions of that. So we have load balancing, which is one of the ways we do it. The second way is we essentially summarize routes. So a subunit would only know about all of its endpoints in its area, and then with CBR, our CBR has this thing called a fib, which is basically we're using an overlay network. Mm-hmm. So we essentially make an overlay network, so your underlying topology doesn't matter. And we use UUIDs to identify every single endpoint. Those are basically summarized, and there's a default route to its next higher level, sort of like the internet with BGP. You sort of have, you have your default routes that go to each higher level. And every time you go to a higher level, you handle more and more and more and more, because I don't have to know about all 10,000 endpoints. I only have to know, like in DNS, that this one CBR controls those 10, and that's how it's to get to them.
Okay.
We also do labeling. We do some labeling like MPLS. So basically, we label the flows so we're able to tell where things can go, so it keeps the routing traffic down to a minimum. And finally, for scale, we one of the reasons why we chose not to do it ourselves was we're essentially breaking the problem up. Every single company has its own infrastructure, so even if our stuff is slow, their stuff will still be fast, however much they want to do. We can cluster them. There's a lot of clustering we can do locally. But the most important thing is we can handle up to 100 million with the different layers. If you look at 10,000 per layer, it's like a power of 2 every time you go up another layer.
Right.
So basically, the architecture scales. We optimize for 10,000, and then we summarize up from there. So basically, if you think of a building, an average building will probably have maybe 100 to 1,000 lights. Mm-hmm. Up to, and our own, like 10,000 is more than any of our installations we've ever seen. So we figured 10,000 was sort of the sweet spot of what we needed to hit, which with our existing infrastructure with just one VM, we can handle 10,000 tenants. So we don't have to worry about scaling for a while. And if we're doing that well, then we can afford more Microsoft images.
Right. And and you didn't dig into it much, but you decided to use the Microsoft Azure Cloud to help you guys deal with the scaling. Can you talk a little bit about?
We did. It was sort of where Microsoft shop. It was a path of least resistance.
Okay.
The nice thing about the way we've designed it, we could use any cloud.
Okay.
We could use Azure, we could use Amazon, we can use VMware, we can use Citrix, on-prem. We can even do bare metal if you really want.
Okay.
So the design process is that we can use Ansible to automatically create you an appliance that'll work in whatever network you need within a very short period of time, less than a day.
Okay, very cool. So, I think what I'm hearing from you is, you've been able to take a bunch of experience you've had in the past. So, principles of sort of multi layers of security, software-defined networking, and how to deal with large complex routing. You're using Ansible to automate all this because obviously, as you add new companies or new devices, that just needs to sort of come online and happen. What other lessons have you learned, especially say within a new organization about, how to sort of balance this idea between new technology, communicating it to people, going and figuring out if it works? Like, what other lessons could you pass along to people that are potentially going to go take on an IoT project?
Well, one is don't be afraid to throw everything away and start over again.
Okay.
We've had so many ideas that seemed great at first that just didn't work out. Mm-hmm. Like my first one was I was building the Azure image, and I was using PowerShell, and the way I was doing it just didn't work. So I threw it away and I started over again. The other image is I changed Ansible on its head. Instead of having a central Ansible server, every single installation has its own full version of Ansible. So I can run all my DevOps scripts from an RPM package, and I don't have to control the remote server with an SSH key, which from a management perspective enables us to have a decentralized management model and still use Ansible in a way that it was intended. We just use it locally.
Gotcha.
Even on the endpoints, we have Ansible. So it's kind of interesting. The endpoints themselves can run my Ansible scripts, and that's my lingua franca for the entire environment. And it's proven to be very resilient and reasonably secure because I don't have to worry about SSH keys getting compromised because the customer controls all that.
Right. Well, and we've heard that. We've heard that sort of principle where you take something that was designed to be kind of centralized in one use case, and you sort of, like I know a friend of the show, a woman named Bridget Cromholt, who for a while had worked at a company that did sort of Netflix for anime type, Japanese movies and stuff. And she basically said, hey, look, she was talking about containers at the time. And she said, instead of having one container registry that everything had to come back to, we would put container registries locally on all our machines. And it allowed us to sort of make sure that if we had a failure that was, a domain that we kind of needed to get to, but something, was always locally, you could make sure your services were always going to be running because, the control was somewhat local and the process of having it close to it was fairly lightweight, or the licensing, because it was open source, allowed you to do that. So it's not an unusual pattern, but it's cool that you, like you said, you're able to take an initial idea, throw it away, figure out what the real demands of that use case are, and then adapt to it. So that's really powerful.
Yeah, the final security piece that we're going to be using for our own management is something called a jump host. Mm-hmm. So basically, a jump host is like a really secure box that gets you into the management domain.
Right.
There was nothing out there. I found something this called SSH Keybox, which is basically a wonderful application that does two-factor authentication, full auditing, and manages all the SSH keys for all my devices. So I basically go in, I create a new user, and it automatically distributes them to all my boxes. And then the other nice thing is that the user themselves never gets the SSH public key. So even if their key is compromised, they actually can't put it on different boxes. And more importantly, we can revoke the keys instantly with SSH Keybox. I just delete that user and poof, they're gone. It automatically distributes to all the systems. I'm running that on FreeBSD inside of a jail, hardened BSD. So it's basically a really secure box running inside of a jail, which is basically like a container, with extremely limited privileges. And even the Java applet itself doesn't run as root. So it's a nice applet, and it's very secure. And the auditing is nice too, because I can see all the commands they type, and it's a great protection to the environment.
Yeah. No, it's a really interesting, it's a powerful story. I think, for me, the takeaway, obviously, it's always cool to see local companies here in Raleigh area, doing interesting new advanced technology things. But I think just like from your perspective, it's very cool to see that you've been able to move from one part of the IT industry, reuse some of those skills, move into stuff that people think is pretty cutting edge and bleeding edge. So that's very cool. This wasn't a, oh my God, I what am I going to do with my career? Like you're sort of a good proof point that you can advance in that and you can reuse what you know. The other thing that's I think is really cool is you guys have put a lot of thought into the security of this. And I think that's going to turn out to be very beneficial, because at the end of the day, as people start, you're obviously trying to sell these as commercial systems for people's lighting, for their buildings, their warehouses, whatever, hospitals. But as more, business people are making technology decisions, right? They're trying to digitize their business. They've got to be somewhat comfortable. And when they hear stories about, is my home automation safe? Can people listen in on my Alexa conversations? Like there's a little bit of, yeah, there's a little bit of uncertainty or FUD that might be in their mind. And the fact that you can walk through both technically and visually and help people understand, like, no, we've thought through this scenario, this problem, we're going to take care of this. Like that's really, really important. So, good guidance for anybody that's going to take on a similar type of project address those issues.
And the security through obscurity model is something we don't do. Security with obscurity is fine. Yeah. But security through obscurity is bad.
Right.
And so most of the security is very auditable. One of the things we also, thanks to your show, we use Prometheus to monitor and watch things with Grafana.
Cool. Excellent.
So there's a lot of those components are really nice when we were looking at our TCP sockets descriptors, and we could look at those things in second intervals. With Prometheus, it's a really nice tool for looking into that.
Very cool.
And I guess the last security feature is our boxes keep themselves up to date automatically. Mm-hmm. I use Yum Cron, and the nice thing about Yum Cron is you can say only install security updates, and we reboot once a week, so that just in case at 0 hours UTC on Sunday, all our boxes will reboot, and so just so that they have their the kernel things will be, all the processes will be updated.
Yeah.
It was sort of anyways. So that's the last little bit about that.
Yeah. Well, very cool. Well, listen, Thomas, I'm going to kind of wrap it up, folks. A really good example of, some very new technology. We've been telling you for a long time to get up to speed on open source technologies, learn how to work in those communities, learn how to go find those projects. Get your Linux skills up to date. If they're not already, get your automation skills up to date. Like you said, people can move from one industry to another. All sorts of companies are going to be starting to look at these new types of ways to interact with the marketplace. So very, very cool story. Thank you for sharing all that with us. If people want to reach out to you, let's say they want to do a follow-up somehow, ask you a question, are you reachable on Twitter or any other places?
Yes, Twitter would probably be the most effective way to reach me.
Okay.
And I am at Simgryph, SYMGRYPH.
Okay, and we'll put that in the show. We'll put that in the show notes because that one's a little tricky to remember. So
yeah, I also post quite frequently on interesting security stuff that I do. If people are just interested, I constantly post on like new SBC, small board computers and security stuff, and medical stuff. Anyone cares. And it's just a generic, it's sort of my way of posting to the world interesting things that I find, that I read.
Very cool. Well, listen, we will get those out in the show notes as well. And thank you so much for being on today, folks. We're going to wrap it up with that. So for Aaron and for Thomas, thanks for listening, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.